Assalamualaikum warahmatullahi wabarakatuh. My name is Aqil bin Anas, and today I'll be presenting my final year project with the title of Development of Prototype and Simulation Testing for Automatic Porter Unscramble Machine. My supervisor is Dr. Malek bin Abdul Wahab, and my co-supervisor is Dr. Sukarnur bin Abdullah. Okay, so for introduction of my project is that it's based on a bottling plant in Simperangam Machap, Johor called Eagle Swap Sunamberhat. They are fully owned by Bumiputra and they have started their business in 2007. They have a 200-meter deep well to supply mineral water to their factory. And then there are a few processes to make a bottle of water in the factory, starting from the bottle filling process to cleaning process, capping and packaging, and also to put the bottle into the box. Then which is the bottle filling process is an early stage in the production line, and this is where it is important to have the right bottle flow rate so that it can affect the bottle output. And this is why the implementation of an automatic bottle unscramble machine can help to increase the output. Okay, so problem statement for this project is that the bottling plant is quite difficult to cope with the market demand, as the production is low and the demand is high. This is because the bottle filling process still using the manual labor as in the picture. They have 2 workers to sort the bottle onto the conveyor. Well, this means when human worker, the flow rate of the bottle is inconsistent, and sometimes a slow rate of bottle flow rate can affect the output. And when using worker is also increase in labor cost because of human worker. So the research question for this project is that how does an automatic bottle unscramble machine work? And second is how to design an automatic bottle unscramble machine. And third is how does the automatic bottle unscramble machine prototype affect the new flow rate of the bottle filling process? Then the objective of this project is that firstly to develop a prototype of an automatic bottle unscramble machine. Second, to develop a simulation of the automatic bottle unscramble machine using motion analysis in SolidWorks software. And third is to analyze the efficiency for the bottle flow rate of the automatic bottle unscramble machine by comparing the result of objective 1 and 2. And fourth is to apply the IoT monitoring system to automatic bottle unscramble machine for data collection. Then the methodology used in this project is firstly to define the problem, and then to research on machine element, and then make the concept design of the machine, and then design the prototype model component using SolidWorks software, and then the selection of material. After that, assemble the prototype model component. If the result is acceptable, you can proceed to simulate the prototype model using motion analysis in SolidWorks software, and after that can record the result. Okay, for the methodology in problem identification, we have conducted a site visit to the bottling plant, Eagle Swap Sunamberhat, to identify the problem and also to discuss and brainstorm ideas and solution for the problem with the owner of the bottling plant. And then I also did a research study for literature review of the existing bottle unscramble machine in the market. Then when making the concept design, I have to determine the suitable design and shape for the machine, and I have to consider the size and the area that's gonna be installed the machine. And then I have to select the right mechanism for the machine, as a complex mechanism can make it hard for the user to use. And then third is the material selection. This is important because it can affect the cost of the machine. Okay, third is to draw the design of the automatic buttons from a machine. Uh, um, I draw and design the SolidWorks software individually of the component one by one, and then assemble all parts together in one sheet, and also to make sure the dimensions are all correct, because it will be helpful when fabricating the prototype. Okay, then simulate the design using motion analysis by setting the motor at 100 RPM, and for 6.6 minutes we can calculate how much bottle can be supplied to the production line. Okay, for the results, firstly, the machine specification, we get a bottle flow rate of 55 bottles per minute, with the dimension of 1000 millimeter length, 1000 millimeter width, and 2667 millimeter height. Also, the material is aluminium. Okay, so for the component of the function is firstly the body frame, the base that will support and hold all the component, and then the drum as a cover to protect the component inside, and the bottles. The hopper, it will a place for the worker to supply the bottle to the drum, the rotating disc to help the bottle move from the hopper to the drum and to make sure that no bottles stuck in between. And then the turntable in the drum, which will rotate and move the bottles to outside drum to exit flap. The shaft will connect the turntable and the rotating table, and to make sure that it rotate at the same speed and at the same time. The AC motor will drive the shaft to rotate. The propeller will to ensure the bottle move in one direction and no backflow. And the exit flap will guide the bottle to the flip hook. And the flip hook will sort the bottles to an upright position before falling down the chute, and the chute will ensure that the bottle fell onto the conveyor, and while the conveyor will move the bottle onto the other section. Okay, for the machine process flow, firstly, a box of bottle will be supplied in the hopper by the worker, and then the bottles will go down the drum through the rotating disc from the hopper, and inside the drum the turntable will rotate and move the bottle to the exit flap, and the exit flap outside of the drum will guide the bottle to flip hook. If the bottle is already is not in upright position, the bottle will just fell down the chute, and if the bottle is in upright position, the flip hook will change the position of the bottle before falling down the chute. Okay, this is the simulation using the motion analysis. Okay, the bottle fall down the hopper through the rotating disc, and at the turntable it will go down the exit flap, and then see the flip hook, it sorts the bottle in the upright position. Okay, so from the simulation we obtained that for 6.6 seconds it can supply around 6 bottles to the conveyor, and which mean when manually calculated that for 1 minute we can supply around 55 bottles, which is more extra 5 bottles from the existing bottle flow rate, and this means that it can give a lot of differences for month of supply. Then this when the designs and the simulation are all give satisfying result, we can proceed for the prototype fabrication, while for now the prototype is still in progress and still not yet finished. Okay, the significance of this project is that this machine can help increase the bottle flow rate with less labor cost, as it uses less human worker, and also the program can be set in a computer to increase the bottle flow rate. And the efficiency of the process also can be increased in the production line, as the production line because the feeding process is the early stage of the production line, and when the first stage is already in the high speed, and then the next process can gain the same benefits. And then it's because this machine is simple and yet is affordable. Other small medium industries can also use this machine for their business. This can help a lot of people. Okay, for conclusion, the mechanism used in the machine are simple yet effective. It works well and also can increase the water flow rate, although the mechanism is simple. And then the machine can help to increase productivity with shortened production time. It's because with just speed of 100 rpm, it can supply around 5 more bottles than the existing flow rate. This means it can increase the productivity. And then the machine can still be improvised to increase capabilities such as IoT monitoring system implementation. This means the machine still have a lot of potential to be increased, and this IoT can help to monitor the data from the machine from just using cloud system. And then lastly, the machine can help to sort and feed the bottle to production line in bottle feeding process. There will no need for human workers anymore to sort the bottle one by one. Then the machine can just sort it like as a bulk. I think that's all from me. Thank you very much. If you have any inquiries, you may reach me at my phone number and my email. Thank you very much.